Hello everyone. In my last video, I have discussed about the greatest integer function. In this video, I am going to do two sums of greatest integer function of continuity and definite integration. So the first sum is let fx is equal to box sin x, where box x is the greatest integer function. Is fx continuous at x equal to pi by 2? So we have to find out the continuity of box sin x at x equal to pi by 2. Now before that, we should have a concept of that sin x, whatever value of x be, sin x always lies between -1 and +1. So sin x always lies between -1 and +1. And to find out the continuity, first we have to find out the left hand limit and the right hand limit of this box sin x at x equal to pi by 2. So let us do the left hand limit. Limit x tends to pi by 2 minus box sin x. Now we know that sin pi by 2 is 1, and since x is approaching from the left hand side of pi by 2, that means when the value of x is slightly less than pi by 2, then the value of sin x is slightly less than 1. So then its box value will be 0. And when we approach from the right hand side, that is when we discuss about the right hand limit, that is limit x tends to pi by 2 plus box sin x. That means the value of x is slightly greater than pi by 2. Now that means x is lying in the second quadrant now. But we know that sign in the second quadrant is positive. And the value of sin x when x is slightly greater than pi by 2 will again be slightly less than 1, because the value of sin x always lies between -1 and +1. So in that case again its box value will be 0. So from here we can say that the left hand limit is equal to the right hand limit. Hence the limit of the function exists. So then we write limit x tends to pi by 2 box sin x is equal to 0. Now to find out whether it is continuous or not, we have to find out the value of f of pi by 2. That is box of sin pi by 2. Now sin pi by 2 is 1 and its box value will be 1. So from here we can say that limit x tends to pi by 2 box sin x is not equal to f of pi by 2. Therefore fx is not continuous at x equal to pi by 2 by the definition of continuity. Now let us discuss one more sum of greatest integer function of definite integration. So the sum is evaluate integration 0 to 1.5 box x dx, where box x represents the greatest integer function. Now here, since it is from 0 to 1.5, in between there is an integer 1. Now we know that whenever there is an integer in between, the box value changes its value. So we break it up from 0 to 1 and 1 to 1.5. Now which property of integration we are discussing here? Let me write that first, that if a number c lies between the upper limit and the lower limit, then we can break up the integrand a to b fx dx to integrand a to c fx dx plus integration c to b fx dx. So like this we can break it up. So this is the third property of definite integration which we will use here. So this 0 to 1.5, 0 to 1.5 box x dx, because box x we don't integrate, first we cannot integrate, so it is a constant value, we have to put it there and then only we can do the integration. So I am breaking up this limit to 0 to 1 box x dx plus 1 to 1.5 box x dx. Now the box value from 0 to 1 is 0. So here we are writing 0 to 1, 0 into dx, and from 1 to 1.5 its box value is 1. So 1 into dx. Now integration of 0 is 0 and integration of dx is x, and we put the limit 1 to 1.5. And according to the fundamental theorem, we can substitute the value, first the upper limit in place of x minus the lower limit, which we get 0.5. So I hope you find these two sums helpful. So in the next video I will show you more important sums. You subscribe my video and like it and share it. Thank you.